Let's look at question number 6. Below given 5-digit number is divisible by both 4 and 9. Fill the blanks with appropriate digits. Right, we have been given a 5-digit number, but the last 2 digits of the number are missing. So we have to say what should be the last 2 digits. Right. Now, since they've said the number is divisible by 4, definitely the last 2 digits have to be, though the number formed by the last 2 digits should be definitely a multiple of 4. So what could be the last 2 digits? One option is it could be 2 zeros, or as it could be 04, 08, or as it could be 12, 16, 20, 24, 32, it could be 36, or as it could be 40, 44, 48, all the multiples of 4 below 100. So I just wrote a few. So it got to be these numbers, right? Let's put 2 zeros at the end because they have said the number is divisible by 4. Let's put 2 zeros at the end. Right, so what's the number we have got here now? It's 72,300. But they have put another condition. What is it? The number that is here should be, or this number, the 5-digit number, the number that I'm circling in blue, this number should be divisible by 9 too. So there are 2 conditions. The number inside this blue circle, it should be a number divisible by 4 and also a number divisible by 9. Right. Now, how do we determine whether a number is divisible by 9 or not? What is the test we do? The test we do is we check the digital root of the number. If the digital root of the number is 9, then that number is divisible by 9. So let's look at what's the digital root of 72,300 is. 7 plus 2 plus 3 plus 0 plus 0. When we add the digits, we get 9. 9 plus 3 is 12. 12 plus 0 is 12. So what's the digital root? 1 plus 2. What is 1 plus 2? That's 3. Which means 72,300 is not divisible by 9. Why am I saying so? As I told you a while ago, a number is divisible by 9 only if its digital root is 9. Or else there's another way to check whether a number is divisible by 9. It is when you add the digits. If you are getting a multiple of 9, then that number is divisible by 9. What does that mean? Now, when we add the digits, what are the digits here? 7 plus 2 plus 3 plus 0 plus 0. When we add the digits here, what do we get? 7 plus 2 is 9, 9 plus 3 is 12. Is 12 a multiple of 9? What are multiples of 9? 9, 18, 27, 36, 45, the 9 times step. Is 12 a multiple of 9? No, it is not. Then definitely 72,300 is not divisible by 9. So here, though 72,300 is divisible by 4, it is not divisible by 9. So therefore, putting 2 zeros at the end is not the correct way to fill the blanks. Right. Shall we put the next multiple of 4? The next option, since they have said the number is divisible by 4, let's put 04 at the end. So now 72,304. It is a number divisible by 4. But that check alone is not enough. Now we have to check whether this number is divisible by 9. How do we check? Add the digits. 7 plus 2 plus 3 plus 0 plus 4. What do we get? 7 plus 2 is 9, 9 plus 3 is 12, 12 plus 0 is 12, 12 plus 4 is 16. Is 16 a multiple of 9? Does 16 come in the 9 times table? No, it does not come, which means 72,304 is not divisible by 9. Now, we can't keep on writing digits like this. It's going to take a lot of time. It's time consuming. So let's think of a quicker method. So what's the quicker method? First, you add the digits which are already there. That is 7 plus 2 plus 3. What is 7 plus 2 plus 3? That gives us 12. Now remember what I said a while ago. If a number is divisible by 9, when we add the digits of that number, we will certainly get a multiple of 9. So what is the closest multiple of 9 to 12? What is the closest multiple? What is the closest multiple of 9 to 12? Let me write the multiples of 12 in green in the side here. That's 9, 18, 27, 36, and the list keeps on going. 45, 54, and so on. So to get a multiple of 9 when we add the digits, what should be the addition of the two digits what we are writing here? 12 plus what? 12 plus what would make 18? 12 plus 6 is making 18. So the addition of the two digits what we are writing in the blanks got to be 6. So from where should we select those two digits? We can't just write any two random digits. We have to take from multiples of 4. Why should we take from multiples of 4? Because they have said the number what you're writing, this entire number, what I'm circling in green now, this number has to be divisible by 4 too. So let's check for a multiple of 4, which would give us an addition of 6. Does 12 give us an addition of 6? No, 1 and 2 is 3. What about 16? 1 and 6 is 7. What about 20? 2 and 0 is 2. What about 24? The addition of 2 and 4 is 6. Alright, we found a multiple of 4 whose digits add up to 6. That is 24. Now, what can we say about this number 72,324? Since the last two digits is 20, since the last two digits form the number 24, 72,324 is divisible by 4. Is it divisible by 9? Yes. When we add 7 plus 2 plus 3 plus 2 plus 4. When we add all the digits, what do we get? We get 12 plus 6, 18. So 18 is a multiple of 9, which means 72,324 is divisible by 9. So 72,324 is a number divisible by both 4 and 9. Right, do we have any other options? Other than writing 2 and 4, any other options? Right, let's check. So this is one correct answer. Let's check for other correct answers. Is there any other multiple of 4 which would give us 6 when the digits are added? There is no. Alright. Yes, that's a good one. Yes. 60. What about 60? 60. When we add 6 and 0, what would we get? What would we get? We get 6. So we can write 6, 0. So this is another answer. 72,360 is divisible by both 4 and 9. Alright, so that's the second option. Any other? Any other multiples of 4 whose digits add up to 6? Alright, yes, there are no any other 2-digit multiples of 4 whose digits add up to 6. So now we are done with trying to get 18. Now let's try to get 27. So to get 27, what should we add? What should we add to 12? 12 plus what makes 27? 12 plus 15. 12 plus 15 is 27. Right. So what are the multiples of 4? What are the 2-digit multiples of 4 whose digits will give us 15 when added? What about 16? No, 1 plus 6 is 7. It doesn't give us 15. How about 32? 3 plus 2 is 5. No, we don't. Shall I continue this list for your ease? Like 60, after 60 was the next multiple of 4. 64. After 64 comes 68. 72. 76. 80. 84. 88. 92, 96. Alright, I have written down all the multiples of 4, all the 2-digit multiples of 4. Out of these multiples of 4, which multiple of 4 give us 15 when the digits are added? Shall we check 76? When we add 7 and 6, what do we get? 7 plus 6 is 13. No, we are not getting 15. How about 96? What about when we add 9 and 6? What do we get? 15. Which means we can fill this blank with the digits 9 and 6. Now when we put 9 and 6, this number, what I'm circling in green, 72,396 is divisible by 4. Why? Because 96 is a multiple of 4. Is it divisible by 9? Yes. Why? Because when we add the digits 7, 2, 3, 9, 6, the answer is 27. That's what we planned. We want to get the answer 27 when the digits are added. So definitely 72,396 is divisible by both 4 and 9. All right, all clear?